same meal. Foods that contain dairy products are referred to as milchig. Milchig. Write that in your copybook now. Experiment 2. An experiment was carried out to determine whether calcium is a conductor of electricity. First, a simple electrical circuit is constructed. The negative terminal of a 9-volt battery is connected to one end of a Besselheim plate. The other end of the Besselheim is connected via an electrical lamp to the positive terminal. Now for the calcium. A quantity is gently poured into the Besselheim, making sure that it forms an unbroken line between the negative and positive end of the Besselheim. If calcium conducts electricity, the circuit will become complete and the lamp will light. Sadly, the lamp does not light. From the results of this experiment, we can conclude that calcium does not conduct electricity. Now let's see what happens when we introduce some sodium chloride. You'll recognize it as common salt. Let's take a look at the lamp now. The calcium has reacted with the sodium chloride to produce calcium chloride. Because calcium chloride is a conductor, the little lamp lights. Small quantities of Thomason's oil, segnomin, are also produced. Little wonder that calcium chloride is used to power amplifiers for electric guitars. When calcium is burned, calcium oxide is released as a vapor. Although not toxic, if inhaled, this vapor can cause temporary bodily paralysis. For centuries, magicians have been using calcium to simulate levitation. This principle can be demonstrated in the laboratory. Experiment 3. An experiment was carried out to observe the effects of helium gas upon calcium. A pyramid of powdered calcium is formed upon a work surface. Next, an ordinary ping-pong ball is placed carefully on top of the pyramid. Now we mark the midpoint. Then helium gas is released in the vicinity of the pyramid. As our starting pressure, we are using Cinderford's constant of 2.5 coulomb per second. Observe the reaction and note the results down in your copybook. The pyramid of powdered calcium has disappeared. Or has it? The calcium seems to have moved some 8 inches away from its original location. 8 inches. So, what's keeping the ping-pong ball aloft? Surprisingly, the pyramid of powdered calcium is still there. Only its image has moved. This phenomenon is known as calcic image misplacement, or CIM. Turn off the helium supply, and the image of the pyramid of powdered calcium is reunited with the actual pyramid of powdered calcium. Now let's see what happens when we increase the flow of helium by a factor of 5 QPS. The pyramid's image fades as before. This time, it reappears some 11.5 inches away. 11.5. Write that down. Now, we try a factor of 7. This time, the image of the calcic pyramid appears over 500 miles away. We've talked a lot about calcium, atomic weight 44. But what of its sister element, calcium atomic weight 42, or intelligent calcium? Intelligent calcium is not intelligent in the sense that you or I are intelligent, but intelligent in that it is sentient, i.e., it is aware of itself and its surroundings. In the laboratory, scientists are able to communicate with intelligent calcium using a REMS oscillating converter. The REMS measures tiny chemical impulses from within samples of intelligent calcium. Experiment 4. An experiment was carried out to demonstrate the cognitive properties of intelligent calcium. The REMS is connected via its 2 thin probes to the sample of intelligent calcium. Once the microphone is in place, we turn on the REMS. Get ready to take down readings from the screen. The scientist issues interrogative statements to the intelligent calcium through the REMS, which measures its response.
What is your atomic weight?
It can take a few moments for the sample to respond. The scientist repeats the question.
What is your atomic weight?
There we are. F O R T Y T W O 42.
Where are you?
I N A T E S T T U B E in a test tube.
How do you feel?
C O L D. Cold. Now watch what happens when we deprive the intelligent calcium of oxygen. The intelligent calcium is completely neutralized. Note that down in your copybook now. Over the course of this module, we've learned a lot about the nature, manufacture, and uses of the white element. But remember, whether you're at home, in school, or just out and about, whatever you do, never give a gypsy calcium. Now hand in your copybooks to your teacher or head of class. In the next program, we will look at champagne.